So we've got two different ways we can graph points. One on the rectangular grid, the x comma y coordinate system. And the second is the polar grid, which is r comma theta. Okay, how far we travel out from the pole, and then the angle from which we rotate from the polar axis. Okay. So in this video, we're going to talk about graphing on the polar grid. Okay. So an equation whose variables are polar coordinates is called a polar equation. So a polar equation, okay, the graph of a polar equation consists of all points whose polar coordinates satisfy the equation. Okay, so first thing I'm going to do is I'm going to identify and graph the equation, the polar equation, r equal to 3. Okay? Now, remember when we convert polar equations to rectangular, things that we know how to graph, one technique we could do is square both sides. And that gets me r squared equals 3 squared. And remember that r squared is equal to x squared plus y squared, which is that circle, okay? That circle with radius r centered at 0, 0. Okay? So this is x squared plus y squared equals 3 squared. So my radius of circle is r equal to 3, centered at 0, 0. So what does this look like in the polar? This is a circle. Okay, so there's my polar axis. We go out. So r equal to 3 means that no matter what theta equals, we always have an r equal to 3. So I go out, so at theta equal to 0, I go out 1, 2, 3. At theta equal to pi over 4, I'm out 3. At theta equal to pi over 2, I'm out 3. 3 pi over 4, pi, all the way around. I'm always a radius in r equal to 3. Okay, and so that r is constant, equal to 3 always. That's what that's saying there. Okay? So that is my circle. R equal to 3 is the same thing as x squared plus y squared equals 3 squared. Let's try another one. Okay? So graph theta equals pi over 4. Okay. So how do I convert this to rectangular? First thing I'm going to do is I'm going to take the tangent of both sides. So that gives me the tangent of theta equals the tangent of pi over 4. Now, luckily, the tangent of pi over 4 is 1. And so this is y over x. Remember, tangent y over x, right? Tangent theta is y over x. Cosine theta is x over r, and sine theta is y over r, just for your memory. And so if I solve for y here, I'm going to multiply both sides by x. So I get y equals x. So what is this? So to graph this, got my polar axis. Now what this says is that no matter what r is, theta is always pi over 4, right? So if r equals 0, we're right here. Okay. If r equals 1, I'm right there. So remember, it's pi over 4. If r equals 2, I go out 2. If r equals 3.14159, 2, blah, 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 I'm going out right there. And so I just continue going forever for all r. Okay, so this represents theta equal to pi over 4. Now, if you think about it in the xy plane, if you graph y equal x, it looks just like this. So that's y equal x. So not only does this work for positive r's, but it also works for negative r's. Okay, so maybe over here it's like negative 2 comma pi over 4. Okay, negative 1, negative 3, whatever. So it gives me this line right here, that y equal x line. Okay, so think about what we just done here. It's like, you kind of think about your y equal to 0. Okay, this is a horizontal line in the xy plane. And then the x equal to 0 is that vertical line. Okay, so that vertical line in the xy plane, the rectangular plane, those are special cases. Just like if I have r equal to 0 or r equal to a number. So let me summarize that. So r equal to some number is a circle of radius equal to that number. Okay. And theta equal to some number, okay, is a line y equal some number, or actually I guess it would be the tangent of that number times x. Okay, so for that problem we just did, the tangent of that number was 1, and that's why it was y equal to x. Okay, so kind of your general cases going on there. Okay, let's try to identify another graph. Let's do a graph of r sine theta equals 2. R sine theta equals 2. Okay. Well, what do we know? We know that the sine of theta equals y over r. So I can replace sine of theta with y over r. So my r's cancel, I get y equal to 2. Now y equal 2 is a horizontal line. Okay, so if I graph this, this is what it looks like. Y equal to 2 here. So in the polar axis, the graph here This is the graph of r sine theta equal to 2. Okay. Let's try another one. Let's graph r cosine theta equals -3. Well, the cosine of theta is x over r. So that tells me that I replace cosine theta with x over r. And what do I get? Well, I get x equals -3. This is a vertical line. X equal to -3. We cross through at -3 here. This is saying no matter what y equals, I could have a y equal to 1, 2, 3, 4, whatever, -1, -2, whatever. X will always be -3. That's that vertical line. X equals -3 there. So in my polar, okay, polar graph, go out 3, and so that's the equation, r cosine theta equals -3. Okay, so in general, if I have r sine theta equals some number, okay, this is a horizontal line. It lies a number units above the pole if a is greater than or equal to 0. And it lies absolute value of the number units below the pole if a is less than 0. Okay. And then r cosine theta equals to some number is a vertical line. And it lies the number of units to the right of the pole if the number is greater than or equal to 0. So just like that number greater than or equal to 0 there. And then it lies the absolute value of the number of units to the left of the pole if a is less than 0. Okay, at a being my hashtag, my number there. All right. So now let's do another type of graph. We're going to graph R4 sine theta. Okay, R4 sine theta. Try to figure out what's going on here. Well, I'm kind of missing my R's now. Let me replace sine theta. Okay, sine theta is y over r. So this becomes r equals 4y over r. We'll multiply both sides by r. So I get r squared equals 4y. Now r squared is x squared plus y squared. Okay, so I'm going to move my 4y over. So I have x squared plus y squared plus 4y equals 0. Actually, that's a minus 4y, sorry. Now I'm going to do complete the square here. So I half it, I get -2, and I square it, I get 4. So what's that going to be? That's going to be x squared plus, and then I have y squared minus 4y plus 4, and then minus 4 equal to 0. Okay, so that's x squared plus, and this factors to y minus 2 squared. And I'm going to add this 4 to the other side, equal to 4 on that side there. Now 4 is equal to 2 squared. So this is a circle with radius equal to 2, okay? Centered at, well, the x value is 0, but the y value we're shifted to the right 2, okay? So if I I'm shifted up 2, okay? So what's going on here? What does this graph look like? It's a circle centered at 0, 2, and the radius is 2. There we go. So it's 0, 0. This is 2, 2. This is 0, 4. And this is -2, 2. Okay? So the graph of that is a circle. All right, let's try another one. I want to graph r equals -2 cosine theta. Now I know cosine theta is x over r, so this becomes r equals -2 x over r. Multiply both sides by r. I get r squared equals -2x. Same thing, x squared plus y squared equals -2x. Add 2x to both sides. And then I do complete the square again, half it, get 1, square it, still get 1. So I'm going to add in 1, but I'm also going to subtract out 1, so that I keep it the same equation, complete the square. So this completes the square root of x plus 1 squared, and then plus y squared equals, I'm going to add the 1 to both sides and get 1 over here. So this is a circle centered at -1, 0. So I move to the left 1 and 0 for the y, with radius equal to 1. Okay, so what does this polar graph look like? I'm centering right here at -1, 0, radius of 1. So something like that right there. Okay. So, kind of might help you out here. So here's a theorem. Let A be a positive real number. Okay. Then R equals 2A sine theta is a circle, radius A, centered at 0A. Okay. R equals -2A sine theta is a circle, radius A, centered at 0, negative A, okay? R equals 2A cosine theta is a circle, radius A, centered at A comma 0, and R equals negative 2A cosine theta is a circle, radius A, centered at negative A comma 0. Each circle passes through the pole, okay? So the method of converting a polar equation to an identifiable rectangular equation to obtain a graph is not always helpful, nor is it always necessary. Usually a table is created that lists the several points, and then we just kind of connect the dots. Okay, so we're gonna leave it there, just kind of summarizing all of the different equations that we've gone through so far.